In this assessment, we're asked to give the structure that corresponds to the name on screen. This is going to be relatively straightforward until we get into the stereochemistry, but we'll talk about that as we get to it. To start, we're going to recognize that it's a cyclohexenol, which implies that it's going to have a double bond, a hydroxyl group, and be a six-membered ring. Now you'll note that there's a 3 in front of the ene. That tells us that the alkene starts at carbon 3, but there's no number in front of the OL. That implies that the hydroxyl group will be at the 1 carbon, so we don't have to specify when it's at the 1 position. We'll put our hydroxyl group here to start. Note we're not showing stereochemistry yet. If this is carbon 1 and we count, let's say, in the counterclockwise direction, we'll go 1, 1, 2, 3. That's where our alkene will start. Carbon 4 will be here, carbon 5 will be here, and that's where our methyl group is. This molecule is 5-methyl cyclohex 3-enol. Now, we have to make this carbon here of the S configuration. We'll start with that one since it's going to be a little bit more straightforward. We know that there's a hydrogen shown here, but we have to decide whether it's going to be coming towards us or going away from us based on that stereochemistry. So we can prioritize the carbons. All 3 are carbons, they're tied. This carbon is attached to 2 because of the phantom atoms, this to 1, and this to none. So our priorities will be 1, 2, and 3. We'll note that counting from 1 to 2 to 3 is going in the clockwise direction. And since we want this to be in the S configuration, we know that means that the hydrogen must be coming towards us. And so we can modify this by drawing in the hydrogen coming towards us, and we can make our methyl group a dashed bond. We'll redraw it in just a second. But we know that that methyl group must be going back, the hydrogen must be coming forward. When we come over to do the same thing for the hydroxyl group, it gets a little bit tricky. We know that the oxygen is going to be the first priority, the hydrogen that we haven't shown is going to be the 4th, but what about numbers 2 and 3? Well, if we look, we have 2 carbons, both are attached to 1 carbon, they're tied. When we go to the next, so we start here, they're tied, we come to here, this one has 2 carbons because of the phantom atom, this one has 2 real carbons. So then we would technically come in both directions to this one, both are the same, and then we would go to here, we would end up with this situation where it seems like it's tied all the way around, and yet we know that this is a stereocenter. And so the tiebreaker is going to be that this carbon is attached to 2 real carbons. Okay, we don't often use that as a tiebreaker, but we do in this case. This carbon is attached to 2 real carbons, whereas this one was attached to 1 real one and 1 phantom atom. And so that's going to make this the number 2 priority. This is the 3 priority. Now we want this to be the 1R. We're going in the clockwise direction. Clockwise with the lowest priority substituent back is the R stereochemistry. So we can draw the hydrogen going back and the hydroxyl group coming forward. If we want to clean that up just to make it a better structure, we can draw this as our final answer.